So why don't we just jump into the FFmpeg issue? What's going on with multi-threaded performance with FFmpeg? What are the symptoms? What are the causes? And how do we work around it?
So we're going to talk a lot about, multi-thread, multi-threading. So first, what is a thread? So a thread is a sequence of instructions, that things that you want to do sequentially. So you cannot do them in parallel. If you want to do this, if you want to do things in parallel, because you have many cores on your computers, for example, so your computer is able to compute in parallel, then you need to have several threads. And these threads, most of the time, are not all the time, but most of the time are said kernel threads. It's an object that is understood by the kernel of your operating system that's handled by a component that is called the scheduler. So the scheduler analyzes which threads are running, which threads are eligible for computing, and it handles all of that. More specifically on FFmpeg, for your question, FFmpeg is a multi-threaded application. And so there are several levels where it's multi-threaded. There can be like a codec that can be multi-threaded. When you execute, for example, x264 or x265 as a library inside FFmpeg, they create their own thread. But also FFmpeg creates its own thread, the application FFmpeg.
So what was I experiencing when we saw a drop in throughput with, and let me just, typically the operation was large file length, say 4K, and then a pretty complex encoding ladder out, say 5 or 6 rungs, and testing HEVC because it's 4K output, and H.264 doesn't make sense. What's happening in a it's a pretty simple command line, right? We do it all the time, but what's happening that causes throughput to drop?
It's not an easy question. So first, I think there's been an effort in FFmpeg to try to bring more threads at the application level. So that's what I was saying. There were not so many threads. I think in FFmpeg 5, one of the big changes is that now when you have multiple outputs, each of these outputs run in a separate thread, which means that, for example, if you have 2 outputs connected to 2 different servers, there is a problem on one of the outputs, the second one is not hung. So they can run in parallel. When it comes to 4K, it's a really huge question. I think there are many factors that affect performances when you're trying to reach the limits of computers. There are threadings, of course. If you're not threaded enough, or if you have too many threads, also maybe that's something that we may want to talk about. Then you're not going to run at your maximum speed. But there is also IOs, right? If you don't deal with IOs correctly, then you can be limited by your IO, so the input-output. And there is also some memory issues. For example, so we're going to compare maybe with the other frameworks, but in FFmpeg, the queues are really large. If you queue a high number of decoded frames that are pretty large by themselves, then it can take several gigabytes of memory. So RAM is cheap, but if you don't have enough RAM, then it's going to write to the disk, and then it's going to be super slow.
Interesting. How do you mitigate that? And if you're working with a command string as opposed to, I guess more programmatically, is there any way you can mitigate against that?
So FFmpeg is 2 parts, I think, for most of the people. There are some libraries like libav codecs for the codecs, libav format for the demuxers, muxers, network protocols, and a bunch of others. And then there is the FFmpeg application. There are other applications in FFmpeg. There is ffplay, which is a simple player. There is ffprobe to inspect your content. And the efforts that I was talking about are on the FFmpeg part, which means that other people were able to leverage some of the benefits that the FFmpeg developers are trying to implement, because they directly integrated the FFmpeg libraries. So when you consider big companies like Vimeo, YouTube, or other projects like GPAC, we integrate the libraries, and we could investigate with some improvements on the performances. FFmpeg is really great for this because you can plug at many points, like for the IOs or for the memory allocators or for the threading, and you can do your own stuff. Not everything is solved on the FFmpeg side, but as I said, they've been working on it. So exciting.